Alright, two fundamental things that we're going to start our notes with when we're talking about complex numbers or imaginary numbers. Anytime it says complex, that just means we're going to have an imaginary number involved. I squared. Let me write that again. I tried to dot my I and it looked like a T. I squared is always -1. Okay? I squared is always -1. Which means that I would be the square root of -1. Okay? Now, these things, people say, oh my gosh, we got an I in there, and they start panicking and freaking out. This is not hard to do. Okay, just because we might not fully grasp where the I comes from and all that, and I'm not going to lie, I wasn't at the math party when they made up the rules. I don't know exactly a lot of things about how to use that, but I can still do what's needed with it. So it's not really all that difficult. If we stick with that 25 that we had in the bell work, and I asked you for the square root of 25. Okay, here's going to be our thought process on this. Anytime we have a negative underneath the radical, okay, we know if you type square root of -25 in your calculator, it's going to tell you error, because you can't take, nothing times itself can make a negative. You get that, right? Because a positive times a positive makes a positive. You've got to be times itself. A negative times a negative, because it's got to be times itself, makes a positive. So you can't get that negative underneath there and still be a real number. The I, that makes it non-real. Imaginary is non-real. So anytime we have a negative under there, that's the same. Yes.
That's right.
Yes.
Do you want to hold your iPad, your Chromebook training in your room on Friday, the 21st, for the 9th grade teachers?
Yeah, I guess so. Is anybody going to give me some guidance on that, or what do I need to do? Do you know? I need to talk to Withers, I guess?
Let's talk to Mr. Withers.
Okay.
And Miss Davis is who he told me would be doing it.
Yeah, he told me I was doing it, but that was it. So I'll have to talk to him. But yeah, my room will be good.
Okay, I'll set it up for that.
Thank you.
Thank you.
So anytime I got a negative underneath there, that's going to be the same as -1 times whatever's under there. Okay, because we know what the square root of -1 is. Just like we say the square root of 25 is plus or minus 5 and it gets to come out, the square root of -1 is plus or minus I. So I took care of that. So now I have plus or minus I square root of 25. But you know what the square root of 25 is. So this is going to be plus or minus 5I. So you do it the same. It just sticks an I on the end. Okay? So, if I asked you for the square root of -4, what would you say? Plus or minus 2?
I'm sorry. He said just show them how to use it. That's what he said. And he talked to you about it. How long do you want it to last? Just morning?
Oh yeah, we don't need much time.
Or you want an afternoon?
Oh, I like mornings. I'm a morning gal.
Okay.
Thanks. So we just did the plus or minus because we're doing square root. Square root of 4 is 2. And then since it's a negative, we put an I on it. So nothing is any different except for you got the I when a negative is involved. Okay? Right.
So it would be like plus or minus 2.
If it was just square root of 4, it would just be plus or minus 2.
Also, you just add 5.
Yeah.
If there's a negative.
Right. Only when there's a negative. Right.
What's the catch?
Nothing.
Every time there's a negative?
Underneath the square root. Underneath the square root.
What if it's an out? Like,
No, doesn't matter.
you don't even know what to put it. You just have to know.
Well, in our calculators, there is an I in there, but I don't think it does this way.
What if it's not a perfect square?
That's what we're fixing to do next. You're reading my mind. Brooks is ahead of me.
Oh, so that's
No, it's not any harder. This one says the square root of -72. Okay, this is what Courtney was asking. This is where we're next. All right, let me get me a list of perfect squares over here. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81. That's far enough for this problem because I passed 72. All right, what I noticed there on my list of perfect squares is that 72 is nowhere to be found in there, right? All right, so it's not a perfect square. So what I'm looking at, let me go ahead and first off, and you don't have to show all these baby steps, but since it's our first day, I still am going to. Let me first of all know that that's happening, right? Okay, 72. I want the biggest one of these perfect squares. This was yesterday's bill right here. That will go evenly into 72. Will 64 go evenly into 72? No. 64 times 2 would be too big. Will 49 go evenly into 72? Will 36 go evenly into 72?
Yes.
Yes. Okay. This is the same now as the square root of -1 times 36 times 36 times what makes 72? 2. Okay. Now, all that stuff that is perfect squares that we know what it is, it gets to come out and play wiffle ball. Everything else has got to stay in and clean the room. What?
I was wrong. Where that 36 goes in.
36 is the biggest perfect square that goes evenly into 72.
Okay.
And the -1 because it was a -72. 36 times 2 is what makes 72.
Okay. Thank you.
You're welcome. Alright, so I'm going to start here on the -1. What's the square root of -1? I just got that, right? So I'm done with that. He came out to play. What's the square root of 36? 6. I always put my number in front of the letter, so I'm going to put a 6i. 6i got to come out to play. I'm done with that. What's the square root of 2? Stays in the house. It doesn't have a perfect square, right? Stays in the house. I'm missing one thing that y'all missed on the bell ringer. Plus or minus. Good job, Kyle.
You need to find one.
Yes.
You forget where they were trying to.
Y'all should just get some chopsticks.
I ain't that good.
There's a,
Finish me on.
what is it? I know, but what is it he said? If you can do that, you can accomplish anything or something like that.
Well, I can't.
There's a new product here that has Jeffrey Shannon.
Yeah.
I'm pretty sure that he like everyone.
Yeah, he does, he did.
The old Karate Kid is the best.
Yes.
All the originals are the best.
Like
I thought he ate it. I thought he caught it and ate it. That's why I didn't know.
Alright, now somebody said something about a negative out in front a second ago, so let's look at this. Negative square root of -36.
Isn't it negative to stay up?
This is a time when the plus minus is not important to me. Because this tells me that negative out in front tells me which answer it wants. It's specifically telling me, look dummy, I want the negative answer, right? That's all that means there. So what's the, don't worry about it yet, let's just go to a radical. What's the square root of -36? 6i, and then this thing wants the negative one. Bam. Right, because it wanted the negative one, yeah.
I mean, like I did it.
Normally-
that's what I was wondering.
Normally it is understood positive, you're right, normally. But radicals, you've got to account for that other answer. That's all, it's best I got.
Okay, so sometimes it'll be whenever you call it the negative, but there'll never be a time where you have to call it.
Right,
Okay.
right. All right, what about there's another number out in front of
I was about to ask that.
it? Man, y'all are smart.
I was thinking something to ask and then I thought of it and then you said it.
You're in my brain. It's a scary place to
That's
be.
what I said.
Alrighty, is 54 a perfect square?
No.
We got 1, 4, 9, 16, 25, 36, 49, 64. Nope. I passed 54. No 54 in there.
It's 9 times 4.
Or nothing.
9 times 6. Okay, Kylie says that this is going to be 2 times the square root of -1 times 9 times 6. Now let me ask you a question. What if Kylie had missed 9 and went with a 4?
Then that would have ended up making a
What's
perfect square.
how many times will 4 go into 54? It might not even. I might have picked a bad example.
So
13.5.
So what I was trying to get you to think about is, what if I pick a smaller one that goes into it evenly when there's still a bigger one? What would happen?
Wouldn't it have more
It'd be
steps?
more
Right,
work.
right. You could eventually get the same answer, but you would have more steps in simplifying. If you pick the biggest one first, you're taking care of it. So that's why I always, once I find out, I start at the biggest one and go backwards. All right. So when we bring all this out, this 2 that's already out here, what operation is the 2 going to do with this stuff?
Multiply.
Multiply, which is distributed. That's right. So square root of negative 1 is I. Done with that. Square root of 9 is 3. Done with that. Still have that 2 out there. What about the 6 that I hadn't touched yet? Stays in there.
And then it's 2 times 3, which would be 6.
So I got 6I, square root of 6, but what do I need to add? Those are not those.
So that 2 is basically just keep writing it down until you get.
Uh-huh.
I feel like the plus or minus is going to be what gets me every single time.
Well.
So I guess if it
All right. Now, when we put these imaginary numbers mixed in with real numbers, standard form, let me make a heading here, standard form of a complex number is A plus BI, where A is the real number, and then obviously the B goes with the I, so that's the imaginary part. Okay? So if I gave you something that said 8 minus I plus 5 plus 4I. This is an addition problem. See, it's got the plus sign in the middle. This is an addition problem of 2 complex numbers. A lot of people look at that, well, I don't know what to do. Yeah, you do. In this case, that I is going to be just like it. We're going to pretend like it's a variable, even though it's not really a variable. We're going to pretend like that. And we're just going to add like terms. Why am I going to add them? Because it's a plus sign in there. Okay, so I would look at this and say 8 plus 5 is 13. Okay, then I got negative I plus 4I. It's a positive 3I. That's your answer. Don't tell me 16I. Why not? Because the 13 doesn't have an I. You can't combine those. That's standard form. Your real and your imaginary. Just combine like terms. Do what, sweetie?
How'd you get 3?
Negative 1I plus 4I. This makes it.
This is probably a really stupid question,
Nope.
but I'm just making sure. That imaginary is pointing to the I, not the BI, right?
Well, no, it's pointing to the whole piece.
So,
Because that B would be the coefficient, it would be how many of them you had.
oh, okay.
Like 3I in this answer.
Okay.
I like that.
Yeah.
Oh, turn out when I don't have it. Oh, I can't spell anything. I put MGG.
MGG. Alright, let's do another easy. This one says 13 minus 2 plus 7I plus 5I. Okay, so it looks a little bit different, but it's still just like term stuff. Okay, now that middle piece that's in the parentheses there, that 2 plus 7I, all that's meaning is that I subtract that whole thing from 13. So I have 13 minus 2, which is 11, and then 13 minus 7I. So that minus sign has to go with the 7I also.
Wait.
13 minus 7I. So that's why they put that in parentheses, to remind you you're subtracting that whole thing.
So isn't it multiplied by -1?
Yes, it'll be the same as distributing in a -1, yes.
Since it's the I, you don't change it and then get the,
Bless you. Yeah. I'm not done with this one yet. You got that right. You see another step. You got some I's to combine, right? Good. 11 minus 2I.
I told you it was going to be a catch.
So it's good. Now let's look at some multiplying with them. This one I've got 4i times negative 6 plus I. Okay, Kylie's right. The 4i right next to the parentheses means we're going to distribute it to everything inside the parentheses. During my distributing, I'm going to pretend just like it's a variable. Okay, so that 4i times negative 6 would get me negative 24i. 4i times I, what's I times I? So that'll be 4i squared. Right? I times I, just like x times x is x squared. I times I is I squared. Now on the first page of this note, you wrote down that I squared is the same as negative 1. So this means now negative 24i plus 4 times negative 1. Took the I squared out and put the negative 1 in. What's 4 times negative 1? So I got negative 24i plus negative 4, which is the same as minus 4. Can't leave it there. No. It's not in standard form. Just flip it, right? The real number, my negative 4, needs to come first. So negative 4 minus 24i.
So why can't you use it? Why can't you use it like
Standard form is a plus bi. A real number comes first. Because it's real, it gets to come first. That's the only reason I know. Fake stuff comes last, real stuff comes first. Alright, these are my favorite kind of multiplying because we're going to do FOIL on it. I got 9 minus 2i, and after this we'll solve an equation where we get an I answer, because that's where we need to be. 9 minus 2i times negative 4 plus 7i. Alright, what's different in this one and the last one that we did, the last one, let me get rewind here for a second. This one, that 4i, that's one term. That's a monomial. One term is called a monomial. That's a monomial, 2 terms times a binomial. So all you did is distribute. But on our new problem, 2 and 2, we got a binomial times a binomial. Okay, and there's different ways you can multiply that. My way I always multiply binomial by binomial is I do my FOIL stuff. So I'm going to multiply the first ones, then the outer ones, then the inner ones, and then the last one. Okay, first one in the first parentheses times the first one in the second parentheses, negative 36. Outer, that's the outer edges. 9 times 7i, it's a positive 63i. Inner, that's the middles there. Negative 2i times negative 4, it's a positive 8i. Last, the last one in each parentheses. Negative 2i times 7i is negative 14i squared. I times I is I squared. Now, just like in normal FOIL with no i's, 95% of the time you can combine your like terms in the middle. 63i and 8i, 71i. Now over here with this minus 14, what's I squared the same as? Negative 1. So that negative 14 times negative 1 now makes it a positive 14. And I got another piece of like terms to combine now. What's negative 36 plus 14? There's your answer. Did I do it wrong?
Yeah, it's 71.
Oh, I dropped a 1. I dropped a 1 down through there. Do I need to scoot it somewhere, Malia?
No, it's just like I'm writing it and I'm trying to listen.
Yeah. Okay.
It's my fault.
No, I'm not yelling at you. You're fine.
Is that 79?
Yeah, I forgot to bring a 1 down in a step or two. Because I'm a doofus. I want you to try one of those here in just a second, and then we'll look at solving some equations.
No, we got very good stuff.
Oh, who said this gets hard?
Because there's one that always seems like it's something easy. There's always in every class, like always.
No.
Okay.
You all right? All right, let me let you try multiplying 2 binomials. This one says 3 plus I times 5 minus I. See if you can do that. I do not. What'd you get on your first? Oh. You're going way too fast for me. On your first, what'd you get?
15.
Hey, I'm going right now. Y'all pay attention. Malia, what'd you get on your outer? Well, look at to me what I'll get. Minus 3i. What would I get on my inner? Positive 5i. And what would I get on my last? What's I times I? Squared. Right? Okay. Now, everybody all right on that step? Very good so far? Now we've got like terms in the middle. Negative 3i and 5i is a positive 2i minus, what's I squared the same as? So I got minus, because of that sign, minus negative 1, which turns that to a positive 1. So 15 minus negative 1 is the same as 16. How'd we do? If we did we see where we went wrong?
Yes, but what did you start? You do the inner or the first one. I wrote that down, so I don't know how.
Let me label these things. First, outer, inner, left. Sometimes that looks like a smiley face when I draw those lines sometimes. You got it. Did you get it right? Alright. This thing here says 2x squared minus 11 equals negative 47. The directions say to solve. Alright, last 2 days, Monday we solved graphing. Well, I don't like that, but we did it. Then we looked at taking square roots, which is what your bell ringer reviewed you over. And then we focused a lot on factoring. Okay? But what I notice on this one, I've got an x squared, which means I got an a. I don't have an x to the first, which means I don't have a b. When we don't have a b, the way you're going to solve is by doing the square roots. Okay, so right now, I want to start trying to get that x all by itself. So what would I do to start getting the x all by itself? Add 11 to both sides. So that would get me 2x squared equals Is that negative 36? Is that right?
Yes.
Okay, just trying to solve this algebraically for x. My x squared is being multiplied by 2, so I would divide by 2. So it gets me x squared is negative 18. Now, x squared is negative 18. This is what we started today's lesson off with.
So it's negative 1 times the
So,
square root of negative.
x is going to be the positive or negative, because I'm undoing the squared by square rooting, right? Square root of negative 1 times 18. Is 18 a perfect square?
No.
What's the biggest perfect square that'll go evenly into 18? 9. So this is going to be the square root of negative 1 times 9. How many times does 9 go into it? 2.
Do you close your eyes or no?
Yeah, we do. Sorry.
How do we know if we don't?
Only if they are, just put a negative out front, like that one problem had a negative out front. Alright, what's the square root of negative 1? Done with that. What's the square root of 9? 3, done with that. What's the square root of 2?
Stays in the
Stays in the house, didn't clean his room. A kid. Alright. What if this one said f of x equals 4x squared plus 20? Okay, so this one they're throwing you for a loop because they put that f of x in there. How would I start trying to solve this? And that's the reason I wanted to show you, just to remind you that different things start off differently. Yes, f of x is the same as y. Yeah, I get that. But remember when we talked about finding these solutions, we had different names for them. They were solutions, they were roots, they were zeros. Okay? So I need to find the zeros here. So I'm going to set it equal to 0. Now it's just like the previous problem. Okay, so what?
Anytime you have f of x equal, you can just do it equal to 0.
So what would our first step here be? Subtract your 20.
You just change the f of x.
Then what would we do?
How about the
Okay. Then what? How do we undo that squared now?
You do plus or minus the square root of negative 1 times
And then 1's not
Good. Kylie's right. The negative 1's the only thing that can come out. That'll be next square root of negative 1 is I.
and then 5 stays in the
5 doesn't have a perfect square that'll go into it. It has to stay in the house. I know, it's a booger. I always get mad when y'all use like little kid math words, like when we do greater than less than, and you start talking about the alligator eating stuff. Burns me up. I get mad, start yelling and screaming, but then I call that thing a house, so.
What is it technically? Why don't you
A radical. Because we need to learn math words. Not the alligator eats the number.
I don't say
Your alligator eating
Like going
anything.
to play with football and staying.
Yeah, that's what I said. I call that a house, so I'm doing the same thing. And I do say radical,
That
but
just makes it so much more confusing. It seems like such a big word.
It's fun to remember the alligator eats bigger numbers.
It's
but-
easier though.
Yeah.
I'll yell at you when we start saying that.
I don't say it out loud.
Yeah, I say it
I
in
say it in
my
our
head. I'm like doing this. Let me take this one.
Other than that, I don't think I'd be able to remember the sounds.
Yeah.
Okay, see if you can solve that one. Go.
I'm very slow.
We're not in a race. It's okay.
Tell Macy that. She already got the problem broke down halfway through.
Ooh, scratch.
Square root in the top and the bottom. It's okay. It's perfect squares. Oh, never mind. Never mind. She was talking about something different than you.
No, I have the fraction.
No, we have the fraction, but
Okay. When you take square root of a fraction, it square roots the top and the bottom. Separately. That'd have been really mean if it wasn't a perfect square. Then you had to rationalize the denominator. That'd have been really mean. But it's perfect square, so it works out all right.
We can see if I did the shot.
$1.
Well, because we both did
Christmas is less than 3 months away. I gotta buy presents.
Negative 1 times negative 1 is square root.
I want the shot. The fraction? What, negative 1 is
I know.
Is mine wrong then?
And why is that I squared?
Oh, I don't know.
How is my fault?
I did not say anybody was wrong. Sit down.
Okay, tell me.
I can't even see that far away.
That makes sense. Okay.
Yeah. What happened to your fraction?
It's from there, I just,
Wait, well, that over 9 just made me become a 3.
well, the 3 is the 9 and the I is in the 1. The 1 is over there. So,
Where did that 9 go?
over minus I over.
Well, you don't have it. You had a 9 here and you don't have one anymore. Where did it go?
Oh,
I did too, I said mine was 9.
because we didn't
Well,
bring
because
out
it-
X squared.
Well, we didn't write the square because we square root it. So what did we have to do when there was a number? What did we do with that 4? Why did we divide by 4? Because there was a 4 there. So there's a 9 there, you need to divide by 9.
I have X equals and 1 divided by
See, here there was a 2 in front, you divide by 2. Here there was a 4 in front, you divide by 2.
That's why I skipped this step. I have a question. Okay, so set by negative 1 by 9.
And that's square root.
Stays near right. Yeah. Huh? Yeah,
Just gotta serve it up. When you square root fractions,
so that's what I got to do.
you're gonna leave it
Wait, what?
Yeah, okay, now we're square over the square root of negative. So it's X equals 1. Yeah, but you done it all right. And then over the square root of negative. But if they're. No, wait, the columns make 2 different factors. Just make another delta on that. So there's a square root. Yeah. Wait,
Did you finish the book yet?
yeah. So there's the square root of negative plus I.
I thought you meant on
So X equals plus I.
X. Stop telling me that. Don't. 9.
No, I. It's not the square root of negative over what the square root of 9.
Alright, first thing I needed to do was just make my equation set it up equal to 0. Shh. So I'm trying to solve for 0, so I set it up equal to 0. Then, what did I do after that?
Subtract 1.
Good. So I got me 9x squared is negative 1. Now my x squared is being multiplied by 9, so I'm going to divide by 9. So x squared will be negative 1 over 9. Now, undo that squared by square root, and this is where some of y'all started whining about having the fractions. But I gave you friendly ones, so it wasn't that big a deal. You can write it like that, or it's the same thing as if you write it like that. Okay, so I actually prefer this way just so I remember to do the square roots on both. But it's the same thing. Now, this is how most of y'all did this. You said this is going to be plus or minus. What's the square root of negative 1? I. What's the square root of 9? 3. Most of y'all, that's what I saw your answers on your paper look like, and that's correct. Tell me if this is also correct. Yeah, that is. That's not right. Because doesn't this I up here mean it's a 1I? So 1/3 I, same thing, right? Just, you need to know how sometimes they write stuff a little different in case you see it on ACT or something.
It makes you think that the I's gonna go with the 3.
Well, what that means is that whole number is imaginary.
Oh, okay. Oh, because either way it would be imaginary because it's
Right.
imaginary. Okay.
All right. What were everybody all right on that one? Most of the ones that I saw and looked at, you were fine.
So you just have to convert it or leave it the same.
Yeah, I would take either one of those. I just want you to know in case you see it on a test or something. All right, tomorrow, tomorrow we're going to look at our fourth way of solving quadratics. It's called completing the square. If the 5 that we're doing, if I ranked them, the last place would be graphing. This is my preference. Last place would be graphing. Next to the last would be what we're doing tomorrow, completing the square.
So far
Okay.
we have graphing, factoring, and square root.
Yep.
And then tomorrow we'll have our fourth one.
Completing the square tomorrow. Yep.
Are we done?
For today, yeah. Good job.
I like today.